Hi everybody. Today we're going to cover section 6.3 and also 6.4. 6.3 is a pretty short section. 6.4 is going to take a lot more attention. Okay, in fact we're not going to cover all of 6.4 today. We'll just cover half of it and then we'll have our next class to focus on 6.4 some more. 6.3 is entitled Solutions of Polynomial Equations. And the first subheading is solving by factoring. Now we've seen this concept already. If you have two factors like this, x minus 1 times x minus 2, and it's equal to 0, okay. You just set the two factors, each individual factor equal to 0, and you solve. The same principle will apply no matter how many factors you have. So here's a polynomial function, p of x, that's equal to these three binomials multiplied together. Now, when you multiply these out, of course, as I show you in the green here, you're going to have x cubed, right? When these x's hit each other. Then you're going to have an x squared term. You're going to have an x term. And then the minus 1 hits the plus 2, hits the 5. So you're going to end up with minus 10 as your constant term. But you can see this is a third degree polynomial here. In part A, we're asked to find the zeros of this function. So that means you set the function equal to 0. Which means, to solve that, you're going to set each factor equal to 0. So you have this stuff, and you figure out there are these three zeros. Part B, they're just being a little cute in your textbook. They're saying, interpret the same information a different way. What are the solutions of p of x equals 0? Well, that's what we just figured out. When you figure out the zeros of a polynomial, you are in effect figuring out the solutions of that polynomial set equal to 0. Then in part C, it's the same thing. Find the x-intercepts of the graph of the polynomial. Well, you're going to do the same thing. You already just did it. Set the polynomial equal to 0, and you'll figure out the places where the polynomial crosses the x-axis. Let's go ahead and plot those points. X equals 1, x equals minus 2, x equals minus 5. And we also have recognized that the constant term of the polynomial is negative 10. So that's going to be our y-intercept. One other thing, we see that a is the invisible 1, so since it's greater than 0, we know the polynomial is going up like that, and going down like that. Right, since it's an odd powered polynomial, you're always going to have one end going down, one end going up. So that means, and it also goes through here, goes through the x-axis, so we can add that. And it has to go up, go through that x-intercept, and then go through that x-intercept. I have no idea how low it goes here. I'm not going to bother trying to calculate some points and figure that out. Same thing here, I have no idea how high it goes. I mean, I could calculate, I could plug negative 3 in there or negative 4 and get a pretty good idea, but I'm not going to bother with that. And that's how you would handle something like this in example 1. Let me find some more notes here. The root method is the second topic we have here. We've seen for x squared, and this is on page 459 in your textbook, if x squared equals capital C, or notice they use a capital because they mean any algebraic expression, not just strictly a constant. Well, if x squared equals C, then x equals plus or minus the square root of C. We know that from the past. And we've also seen that if x cubed equals some expression C, x equals the cube root of C. Now notice there is no plus or minus sign here because 3 is an odd number. In general, to find the real roots, that's not a C, that's parentheses, to find the real roots of the equation x to the power n equals C, you have to know if n is odd or n is even. If n is odd, x is simply going to be the nth root of C. If n is even, then it's going to be plus or minus the nth root of C, and of course C has to be greater than or equal to 0, because if you had C be a negative quantity, you're not talking real roots anymore, you're talking complex roots. Well, why don't you go ahead and do a couple of these. On page 463, do number 4 and then do number 16. All right, let's see how that turned out. In number 4, we have a binomial being squared, and it's multiplying another binomial being squared. When all this stuff gets multiplied out, of course, it is going to be a polynomial. Well, we know that when you have an algebraic expression times another algebraic expression and it equals 0, that either the first one equals 0 or the second one equals 0 or both. So we set each factor equal to 0 and solve. Now over here I take the square root of each side, right? I have this binomial raised to the power 2. I take the square root of each side and I figure out that 2x plus 3 equals 0. Solve for x, I get x equals minus 3 halves. Over here, take the square root of each side, and of course, what's inside the parentheses, 5 minus x, equals this plus or minus square root of 0 equals 0, just like we saw over there, but I wrote the additional step there. That gives me x equals 5. You can quickly check, let's plug in x equals minus 3 halves. You see what's going to happen on the left-hand side here, when the minus 3 halves replaces x, I start to simplify. I get minus 3 plus 3, right, I get 0 squared. In other words, minus 3 halves is just custom made to make that factor go to 0. And 5 is custom made to make that factor go to 0. So they check out. Let's look at 16. 3x cubed minus 81 equals 0. Well, hopefully you notice that 3 and 81 are both divisible by 3. In fact, they're both powers of 3. Even if you don't, you could solve the problem, but you just have bigger numbers to deal with. Anyway, I'll divide each side by 3 to get to this statement. Then I'll isolate the x cubed by adding 27 to each side. I'll take the cube root of each side. Since 3 is an odd number, I don't have a plus or minus sign to deal with. The cube root of 27 is 3. And we're also asked to plot the function associated with this. So there's my 3, my x-intercept. It's the only one. A is 3. That's a number greater than 0, positive number, so the curve goes up that way, down that way, and in fact I can figure out that my x-intercept is also negative 81, so it goes down through there. And that's a quick way to graph the function f of x equals 3x squared minus 81. Now, the other topic in this section is called factor by grouping. And this is a nice technique, but to tell you the truth, it doesn't happen very often in real life. Right now, we'll see some problems that are designed to make it happen. These problems are contrived so that you have something to work with. But in fact, out in the real world, factor by grouping is not very useful. Still, you need to see it. You have seen it once before this semester when we solved quadratic equations, when we factored quadratics. This was actually one of the steps involved. Let's look at this example. There wasn't a good one in your textbook, so I picked problem number 12 in the homework. That's on page 463. We're asked to solve this. First thing you might notice is there's 4 terms. It's not a quadratic, so you can't use the techniques that you use to solve a quadratic equation. It's of degree 3. There's nothing, and another thing is, there's nothing I can factor out from all 4 of these terms, right? This one doesn't have an x. This one, the coefficient is just 1. So there's nothing I can factor out directly. In this case, the only thing you can do is group pairs of the terms and hope that you're lucky. So I grouped this first pair together. I grouped the second pair together. Notice the sign change when I introduce these parentheses. Causes that minus sign to become a plus. And now, as we did when we factored quadratics, we factor everything out from this pair. And we factor everything out that we can from this pair, which is a 4. Well, lo and behold, it's our lucky day. We happen to have x plus 5 here and x plus 5 here. We can factor that out. And that only happens because this problem is contrived so that the factor by grouping technique actually succeeds. I factor out the x plus 5, and that leaves me with x squared minus 4. And I've got to my situation that I'm always trying to create. I have 2 factors multiplying each other and resulting in 0, so I set each factor equal to 0. On this side, I figure out that x can be negative 5. That will be a solution of this. Over here, I have x squared minus 4 equals 0. Add 4 to each side, I get x squared equals 4. Using the square root method, because I have an even exponent, it's plus or minus the square root of 4, which is plus or minus 2. And of course, it would be pretty easy to check this. You can plug 2, negative 2, or negative 5 in there. It's a bit laborious to do all the calculations, but you'll get 0 if you don't make a mistake, and that should convince you have it done correctly. So now you do it. Do number 14, also on page 463, and let me give you a hint. You have big numbers in there, so why don't you do yourself a favor and divide by 4 to get started. Let's see what you did. Yeah, your coefficients are 4, 8, negative 36, negative 72, all multiples of 4. So I divide by 4, and I get it at least down to there. Well, it's not a quadratic. I see 4 terms, and the biggest one is x cubed. There's nothing more I can factor out of there, because this term here doesn't have an x in it, and I'm stuck there. So the only thing to do is to try factor by grouping. So I'll group these first 2 together. I'll group these second 2 together. Notice when I do that grouping, and I think I'll show that step right there, as soon as I put those parentheses in there, that changes to a plus sign. I can factor out x squared from here. I can factor out 9 from there. Lo and behold, just so happen to have x plus 2 and x plus 2 there. Lucky break. I'll factor that out, and I arrive at this. Set x plus 2 equals 0 and solve. Set x squared minus 9 equal to 0 and solve, and I get plus or minus 3. And you can take any one of those numbers, plug it in there, and it will work as long as you don't make a calculation error. And that should convince you pretty well that you've got it done correctly. So, for homework in this section, on page 463, 1 through 17 odd. That is not a whole lot of work, and should just brush you up on these ideas.